I will just make some corrections no regarding this problem. Yung sa problem number 3 kasi second derivative pala pinapahanap dito, and then yung nakuha ko kahapon is the first derivative only using the central difference approximation. So try natin i-solve naman today yung second derivative nito before we proceed with this problem. Okay? Sige. Ano yung formula natin for the second derivative approximation using the central finite difference? Okay, central finite difference or CFD. Ano yung magiging formula natin, class? For the second derivative, that is, okay, gawin ko lang red ha. For the second derivative, that is equivalent sa, okay, f of x plus yung step size natin minus 2 of f of x, okay, okay, plus yung f of x minus yung step size natin all over h square. Diba? Yan yung formula natin, no? So, meaning to say, we have here f of x, yung x natin is 1, plus yung step size natin, 0.1, minus 2 of f of 1, okay, plus yung f of 1 minus 0.1 yung step size natin, all over 0.1 square. Yan yung step size natin, no? So, kukunin natin yung value of the second derivative at x is equivalent sa 1. So, ano yung value natin sa f of 1 plus 0.1? Ito yun, no? 9.025 minus twice nung f of 1. Ano yung value ng f of 1 natin? So, we have here e raised to the power of 2 alpha x. Calc natin when the value of x is equivalent sa 1. So, that is 7.3891. Okay. Or 7.389 na lang. Times 7.389. Okay? And then, plus, itong f of 1 minus 0.1, that is equivalent sa dito, di ba? So, that is 6.0496. Okay? Okay, sorry. Okay, all over, okay, hold on. Sorry. All over 0.1 squared. Okay. Kung ipa-plug in nyo to sa calculator nyo, so you get, okay, 9.025 minus 2 times 7.389, okay, plus 6.0496 all over 0.1 squared. So, yung makukuha nating sagot is 29.66. So, 29.66. Okay? So, yan yung sagot dito. So, actually, nandito na yan, no? 29.64 lang dito. Kasi, kinuha ko 73891. Dito hanggang 7389 lang. Okay? So, anyway, the same thing lang din. Approximation. Okay? Nakuha nyo ba, class? That is for the second derivative. So, you just need to memorize, no? Yung forward difference. Yung forward difference. May tanong? Okay, forward difference, backward finite difference, saka central finite difference. So, let's try naman dito without, ito yung example ng discrete points. So, walang discrete data points, walang binigay na function. So, may data points lang tayo or a set of data points. So, estimate the acceleration at t or time is 1 second. Okay, 1 second lang yan based on the following readings. So, meron tayong time and velocity table here. So, sa time, say for example, at 0.8 second, di ba, yung velocity based on this data is 12.4. At 0.9 second, yung velocity dito is 13.8. At 1 second, yung velocity is 15.3. Velocity yung pinapahanap, hindi acceleration yung pinapahanap, hindi velocity. Kasi kung velocity, yan yung sagot. Ito yung sagot. Okay? At 1.1 second, yung velocity is 16.9. At 1.2 seconds, yung velocity is 18.6 meter per second. So, ang tanong dito is the acceleration. Diba, from physics, we know that acceleration is equivalent sa, okay, velocity final minus velocity initial over time. Tama ba? Okay. In here, with numerical, tawag ni, numerical differentiation, yung velocity final, we can say that is f of x plus yung step size natin. Minus ito yung f times x minus yung step size natin. At yung time, 'di ba? Kung kukunin natin yung first derivative, basically yung acceleration is the first derivative ng velocity with respect to time, 'di ba? From physics we know this one. So basically, kukunin lang natin yung first derivative ng velocity with respect to time. So mangyayari dito, we have here 2 times time or step size natin h. 2h yan. 2h. Okay. Using our first derivative formula, ito yun, oh. Okay, now, since kukunin natin yung value ng acceleration at time t, so mangyayari niyan, yung x natin is equivalent sa 1. So, ano yung step size natin? H. So, yung step size natin is actually the uniform difference or common difference ng mga t values. So nakikita nyo, 0.8, 0.9, yung difference niya is 0.1. 1 to 1.1, 0.1 din. So, meaning to say, yung step size natin is actually 0.1. Okay, kung kukunin natin to, kung gagamitin natin to, so basically yung f of x plus h, yan yung velocity, no, at 1 plus 0.1 minus velocity at 1 plus minus 0.1 all over 2 times yung step size natin. Ano yung velocity natin sa 1.1? Ito yun, di ba? At time is equals to 1.1. Yung velocity is 16.9. So, 16.9 dito minus yung velocity naman sa 1 minus 0.1, that is 0.9. Ito yun, di ba? That is 13.8. Divide natin by 2 times 0.1. Kukunin natin yung calculator natin. So, that is 16.9 minus 13.8 all over 2 times 0.1. Makakuha natin na value is 15.5. So, basically, that is your acceleration at time is equivalent sa 1 second. So, this is 15.5 meter per second squared or MPS squared. Okay, yun yung sagot dito. So, basically, ito lang yung kapag discrete data points, yan yung process. So, ito is magandang example because we know that acceleration is the first derivative ng time. Pwede din, acceleration is the second derivative ng position with respect to time. Pwede din ito. Using ng physics or dynamics, di ba? Okay, questions with numerical differentiation. Basically, apply lang natin yan ng forward finite difference, backward finite difference, central finite difference. Ito yung pinaka ginagamit. Okay? So, you just need to memorize the first derivative at just the second derivative using uh, central finite difference, yung formula natin. So, ito yung for the first derivative. Okay, hold on. Ito yung for the first derivative at ito naman yung sa second derivative.